Bharat. In today's lecture, I am going to discuss about the basics of digital signal processing. So, in digital signal processing, first we will learn about the term signal. So, generally, signal is nothing but which carries some information is called a signal. Signals which carry some information is called as signal. So, signal can be any kind of signal. So, we have so many different signals: digital signal, analog signal, discrete signal. Okay, so I'll give some example for the signal. So ECG, EEG, and whatever I'm speaking, speech signal. So these are some of the examples for the signal. So we know about ECG. So the ECG signal which gives the information about a function of heart. Okay. So similarly EEG and speech signal. So you can record this signal. So for example, if you are taking a speech signal, so whatever now I am speaking, if you are recording, it will be in the form of waveforms. This can be any shape and structure. Okay. So if you are recording a speech signal, then you are viewing that speech signal. It will be in the form of some different waveform. So it will not be in a periodic manner, because each and every moment there is a difference in the waveform. And then this signal can be of different types: one-dimensional, two-dimensional, multi-dimensional. So first thing, one-dimensional signal. One-dimensional signal. So one-dimensional signal is nothing but signal which depends on one independent variable. One independent variable is called one-dimensional signal. For example, you can say AC signal is a one-dimensional signal. So here we are going to measure the amplitude for each and every instant of time. So we will be getting some values in each and every instant of time. So here the signal depends on the one independent variable called time. So hence this signal will come under one-dimensional signal. So similarly, for two-dimensional signal, the example for two-dimensional signal is, so here example for two-dimensional signal is photograph, and then X-ray images. So these are the examples for two-dimensional signal. So here in two-dimensional signal, one particular signal is depends upon the two independent variables, hence it is called a two-dimensional subject name is called as discrete time signal processing. So we will be considering the discrete type of signal and processing. Okay. So that's why the term is called as discrete time signal processing. Then this signal is classified into two. One is analog signal and discrete signal. So we have different signals: analog signal, discrete time signal, and third type is your digital signal. So here you can find the difference between these three signals. So generally analog signal is nothing but a continuous signal. So continuous signal, continuous signal it means, so this is the waveform for continuous signal. So for each and every instant of time we will be having the amplitude. This is called as continuous time signal. So for each and every instant of time we will be having some amplitude value. So continuous time signal is nothing but the time period is also continuous and amplitude is also continuous. Hence the signal is called as continuous time signal. Then the next type of signal is discrete time signal. So now I will represent the discrete time signal. So discrete time signal is nothing but, from the term itself you can identify the time period is discretized or the time period is divided into n number of samples. Hence the signal is called as discrete time signal. So example, you can see this. So in the x-axis I am taking a month. So this graph is representing a salary credited to your account for every month. Generally, salary will be credited for your account every one day in a month. So okay. So discrete time is, so the time, so for only one particular day in the month of January. Similarly, one particular day in the month of February and one particular day in the month of March. So in this y-axis, I am representing the salary amount. So in the month of Jan, I am getting 200. The month of Feb, I am getting 300. And in the month of March, I am getting 400. And in the month of April, I am getting 100. So for each and every month, that is only one instant occurred in a month. So here the time period is discretized, whereas the amplitude is continuous. So discrete time signal is generally defined as continuous in amplitude and discretized in time period. So this is called as discrete time signal. And third type of signal is digital signal. So digital signal is nothing but the time period is quantized. The time period is discretized and amplitude is quantized. Quantized and amplitude. And discretized time period. Okay. So these are the three different types of signal, that is continuous time signal, discrete time signal and digital signal. So here we are going to use completely, or we are going to completely analyze the discrete time signal. Okay. So next thing, we'll go on to the representation So graphical representation is an example for graphical representation. Here you can see. And then one more thing, the continuous time signal is represented as x of t, whereas the discrete time signal is denoted as x of n. This n is nothing but your sample. Already I told in continuous time signal, the time period and amplitude were continuous, whereas in discrete time signal, the time period or sample, or it is broken into n number of pieces. That is n number of samples. Hence, in discrete time signal, time period is denoted as samples. Hence, x-axis is denoted as n. And this is the function x of n. So, from this I am going to represent the signal. So, it can be minus n. So, representation of signal in graphical manner. So, this is 1 and 2. So this is the representation of a signal in graphical. And then, so the same signal can be represented in a sequence. That is, x of n is your function. Here you can represent this same graph in terms of sequence as 1, 2, 1. So this is the representation of the same graph in sequence manner. So here, this is your origin point m is equal to 0. So generally in some sequence they will be mentioning the arrow along with this term. If this is not mentioned, only the arrow is represented, then it is considered as an origin. That is m is equal to 0. That is 0 sample. That is n is equal to 0. So here you can compare this graph with the sequence. So this is the representation of a signal in a sequence manner. And the next representation is tabular representation. So in tabular representation, so here you can see so if n is equal to minus 1, then the value is 1. If n is equal to 0, then the value is 2. So I am just writing it. I am not comparing with this graph. So if you want to compare also, you can write in this order. That is n x of n. So here the sample will be starting from minus 3, minus 2, minus 1, 0, 1, 2, 3. So if n is equal to minus 3, then the value is 1. N equal to minus 2, then the value is 2. N equal to minus 1, then the value is 1. For 0 is 1, 1 is 1, 2 is 2, and 3 is 2. So this is the representation of a signal in tabular form. Okay. And then the next representation is functional representation. Here the function is x of n. This is equal to 1 for n greater than or equal to 0 and 0 otherwise. This is the representation of a signal in sequence form. Here you can see the condition. If the sample n is greater than or equal to 0, then the value is 1. In remaining cases, that is n is less than 0, then the value will be 0. So this is the representation of signal in a functional format. So if you want this functional format to be represented graphical, here you can write this. So I am going to represent this function format in graph. Here they have mentioned that the value will be 1 when n greater than or equal to 0. Therefore, greater than or equal to, in the sense you want to consider the origin also. So while considering the origin, the value will be 1. Up to n. So in this minus n, the value will be 0. So this is the representation of the sequence in the graphical form. These are the basic representation of a signal. Then the next one is some of the elementary signals, some of the basic elementary signals we will see. So the first type of elementary signal. So first signal is unit step signal. And second one, unit ramp signal. And third one, unit impulse signal. So these are the basic elementary signal. So this unit step signal is denoted as U of n, and unit ramp signal is R of n, and impulse signal is del of n. So here there is a condition for this unit step signal, that is U of n will be 1 when n greater than or equal to 0. So in this condition, the unit step signal will be 1. Here they have mentioned as unit step, hence the amplitude value will be 1. In general step signal, the value can be varied, but as in unit step signal, the value will be 1 when n is equal to 0. N is greater than or equal to 0. Otherwise, it is 0. So this is the unit step signal. So I will represent this unit step signal in the graph. So this will be n. This one will be unit step signal. Consider this value as 1. Here they have mentioned is n greater than or equal to 0. Then you want to start from 0. Sample 0, sample 1, sample 2, 3, until it goes on to n. This is the representation of unit step signal. And next one is your ramp signal. Ramp signal is represented as R of n, which will be n when n greater than or equal to 0. Okay, when n greater than or equal to 0. So consider representation of step signal. So this one is your step signal. That is unit step signal. Similarly, now we get representation of ramp signal. So in representation of ramp signal, here you can see so this is your ramp signal R of n. This one is your origin. 1, 2, 3, 4 samples I am taking here. I am mentioning the value as 1, 2, 3, 4. So here they have given the condition. If for all n greater than or equal to 0, the value will be n. is equal to 0. So this del of n is impulse signal can be represented as n minus n 0. This is del of n is equal to 1. So these are the general conditions for this elementary signals. We will be using these conditions in upcoming problems. Okay. And then, so next thing, we'll move on to the general classification of signal. We have 4 different classifications. One is causal signal and non-causal signal, and the second one is symmetric signal and antisymmetric signal. Symmetric signal is nothing but your even signal, and antisymmetric signal is your odd signal. And third type of signal is periodic signal and aperiodic signal. And the fourth type is the most important type of signal called as energy signal and power signal. So now we will see one by one. One is symmetric and antisymmetric. Antisymmetric is nothing but your odd signal. And third type of signal is your periodic and aperiodic signal. And the fourth one is energy signal and power signal. Okay. So first one is your causal signal and non-causal signal. So here there is a condition for causal signal. The causal signal is nothing but the value of the signal will be 0 when n less than 0. Hence the signal is called as a causal signal. So value is 0 when n less than 0. Hence it is called a causal signal. Okay. Otherwise the signal is called as non-causal signal. Okay. So it means that when the value is 0 when n less than 0. So n less than 0, it means that the sample will be started from -1 to -n. The value should be 0. From 0 to plus n, there should be some integer value. Hence the signal is called as a causal signal. Otherwise the signal is called as an not causal signal. And one more type of signal is also there in causal, that is anti-causal signal. So the condition for anti-causal signal is the value will be 0 when n greater than or equal to 0. So here you can see now I will represent this causal signal. So I am just mentioning it in the sequence format. Okay. So already I told the arrow represents that the sample n is equal to 0. So this is the example for causal signal. So causal signal condition is when the value is 0 when n less than 0. It means that the value is started from the sample 0, that is for 0 the value is 1. When sample n is equal to 1 then the value is -2. N is equal to 2, it is So condition for anticausal signal is the value will be 0. Value is 0 when n greater than or equal to 0. It means that the value from n equal to 0 to n equal to infinity, the value will be 0. So you will be getting the value in your negative side. So that is. So now I will represent this in the graphical form. So consider this is your origin. So example for anticausal signal. So here you will be getting some value. So this from n equal to 0 to, so this side the value is still 0. Hence the condition satisfies. Hence the signal is called as an anticausal signal. So again I am repeating, the causal signal is nothing but the value. The signal will be 0 when n is less than 0. Hence the signal is called as causal signal. Otherwise the signal is, if the condition doesn't satisfy, then the signal is called as a non-causal signal. And one more type is your anticausal signal. In this anticausal signal, the condition for anticausal signal is when the n is greater than or equal to 0, then the value will be 0. Hence, this type of signal is called as anticausal signal. Okay. Then the second one is your symmetric signal and antisymmetric signal. Second one is your symmetric signal and antisymmetric signal. This antisymmetric signal is called as odd signal and symmetric signal is called as even signal. Okay. So here I will represent the signal. I will represent the condition for symmetric or even signal. So for even signal, the condition is x of minus n is equal to x of n for all n. For all n. So this is your equation 1. This is the condition for even signal. So similarly for odd signal, x of minus n is equal to minus x of n for all n. This is your condition for odd signal or antisymmetric signal. Okay. So from these two equations, you can find out the formula for odd signal and even signal to solve the problem. Okay. So here, so the sum of two signals, that is even signal plus odd signal, will be your total signal. X of n is equal to x of, so this E represents your even signal, this O represents your odd signal. Okay. So consider this equation as 3. Now replace this equation by, replace n by minus n. So by replacing x of minus n is equal to xt of minus n plus x naught of minus n. So here you can see same kind of signal here. So this signal is the example. This is the condition for even signal. Okay, so x of minus n is nothing but here we can mention it as xc, because this is for your even signal. So this is for your odd signal. So I am representing it as x naught of minus 1 and x naught of n. So now replace this xe of minus n by xe of n. So and x naught of minus n is minus x naught of n. This is your equation 4. So now we want to add this equation 3 and 4 to find out the formula equation 3 and 4, adding 3 and 4, x of n plus x of minus n, which will be equal to xe of n plus x naught of n, and then plus xe of n minus x naught of n. Therefore, these two odd signals gets cancelled. Then at last 1 by 2 is equal to x of n plus x of minus n. This is equal to xe of n. So this is the formula to find out the even signal. Similarly, if you are subtracting equation 3 and 4, you will be getting the formula for odd signal as x of n minus x of minus n is equal to x naught of n. So this is the formula for odd signal. Okay. Then the next type of signal is your periodic signal and aperiodic signal. From the term itself, you can identify the signal will be occurring periodically. So if you are considering 4 samples, for the repetition of 4 samples will be the same kind of signal will be represented. Hence the signal is called as periodic signal. If it is not in a periodic manner, hence it is called as aperiodic signal. Now I will represent the periodic signal. So the periodic signal, representation of periodic signal, consider the origin form. This sample rate is equal to 0. So it is 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So I am considering 2 samples. So example, I am considering 2 samples, that is n is equal to minus 4. So this will be value 2, this will be value 1. So similarly for second periodic cycle, again for third periodic cycle, and the fourth period. So here you can see the consecutive 2 n samples we are getting the same value. So hence this signal is called as periodic signal. For aperiodic, periodic randomly will be occurring. So here you can see. So continuously if you are checking 2 periods, so it is not in a similar manner. Hence it is called as aperiodic signal. Right? Then the last type of signal is your energy signal and power signal. So the signal can be either energy signal or power signal, or neither energy nor power signal. So here that is the formula to find out the energy signal. So energy signal is denoted as E. So this is the formula to find out the energy signal. The summation n equal to minus infinity infinity modulus of x of n whole square. And for power signal, limit n tends to infinity 1 by 2s plus 1 summation n equal to minus n to n modulus of x of n whole square. So this is the formula for energy signal and power signal. So you can identify the energy signal by this condition. If the value of energy is finite, then the value of power signal is zero, then the signal is called as energy signal. Similarly, for power signal, if the value the power signal is finite and energy signal is infinite, hence the signal is called as a power signal. This is the condition to identify energy signal. If these two conditions satisfy, hence the signal is called as energy signal. If these two conditions satisfy, hence it is called as a power signal. So these are the different classification of signal, that is causal, non-causal, anti-causal signal. Next, symmetric or even signal, anti-symmetric or odd signal. Then the third type of signal is periodic signal and periodic signal. And fourth one is your energy signal and power signal. Okay. This is the introduction about digital signal.